All right, hi everyone. So what we're gonna do next is talk about a couple of different situations that we might be in when we want to use hypothesis testing involving categorical variables. So what we've talked about so far is how to do a hypothesis test when we have one categorical variable of interest, and there's only been two levels. So like either you got the question right or you got it wrong. What we're going to talk about now is how we would do a hypothesis test if we had one categorical variable with more than two levels. And so this is going to be useful partially because it's going to help us review a lot of the stuff that we did involving hypothesis testing previously. So if we have that strong base from before, doing this type of hypothesis test really isn't going to be a ton different. The main part that's going to be different is this calculate part. But we're going to have kind of a similar prepare step, a similar check step, and a similar conclude step to what we were doing before. The data that we're going to use for this example is some Pokemon data. So this is probably my favorite example that we do, just because look at how cute they are. So we're just going to do a hypothesis test involving people's preference for these three starter Pokemon from the original Pokemon game. And so this was a question on the first quiz that you took for this class, is to choose a Pokemon that you prefer. And so based on that data, 13 people chose Bulbasaur, the green plant fella. 17 chose Charmander, the lizardy fire dude. And 26 chose Squirtle, the water turtle type. And so I must say I also love Squirtle, so you guys seem to choose the right one, at least in my opinion, though I also love Bulbasaur, and I guess I love Charmander. Anyway, what we want to see if there's statistical evidence for a preference for any of these. And so the idea being that maybe just by kind of random chance, some people happen to prefer Squirtle a little bit more than the other two based on that idea of sampling uncertainty or sampling variability. Or maybe there is evidence that people actually do prefer Squirtle. And so we want to do a hypothesis test to see how much evidence there is that there is either a favorite or a least favorite starter Pokemon. So some sort of preference involving these three. Our prepare step is going to look really similar. And so we're going to define our parameters of interest. Instead of just one parameter, now since we have three categories, we're going to have to specify three. And so I'm going to denote P with a little b just to represent the proportion of all people who like Bulbasaur best. I'm going to write a P with a little c to mean the same exact thing, but the proportion who like Charmander. And then P with a little s just to denote the proportion of people who prefer or like Squirtle. All right, so these are unknown, but we have some data that we could use to estimate them. In particular, let's visualize our data by drawing a graph. And so take a second to think about what type of graph you draw in this situation. All right, so if we have a single categorical variable, then the graph that we were drawing is a bar chart, which just has count on the y-axis, and then it has our categories on the x-axis. And so just to do kind of a quick sketch, I'm going to draw, I'll make my tick marks by tens. And Bulbasaur goes up to about 13. Charmander's just a little bit higher. And Squirtle is up to 26. Okay, so this is just a quick visualization of our data. Really, it's not that exciting because we just see from the numbers that Squirtle from our data is the most preferred, at least in our sample. And so now we're going to go ahead and write our null and alternative hypotheses in notation and in words. And so if you remember from before, our null hypothesis was either something of like no association when we have more than one variable, and so we're not in that setting yet because we still just have a single categorical variable, or equality. And so in this case, our null hypothesis is that these are going to be equal, indicating that the proportions of preference are identical. Since there's 3 categories, just by definition, then that has to mean that they're all equal to a third. In words, this is just there is no preference for any of the starter Pokemon. The alternative isn't that they're all different from each other, it's just that at least one proportion is not equal to a third. And remember, we're thinking about these proportions as being like the population proportion, so of all people. We know that our sample proportions, they're all different than a third, so we're not testing that. In words, this is just there is a preference or dislike or distaste for at least one of the Pokemon. All right. And so finally, we're going to look at what our sample proportions are. This is the data that we're going to use to kind of evaluate these hypotheses. And so our sample proportion for Bulbasaur was 13 divided by our sample size. And so our sample size is 13 plus 17 plus 26, which is 56. And so that's 0.232. Our sample proportion for Charmander is 17 divided by 56, so that's close to a third. And our sample proportion for Squirtle is 26 divided by 56. Okay, so that's our prepare step. So we could kind of see how it's pretty similar to the prepare step when we just had 2 different categories for our categorical variable. It's a little bit longer in that now we have 3 proportions that we're dealing with that we have to kind of specify in our null hypothesis, but otherwise the step is pretty similar. In the next video, we'll go ahead and go through the check for this hypothesis test, and as well as the calculate step to see how much evidence we actually have that there's a preference for one of the starter Pokemon here.